Okay. Virtual Weekly Contest 366, the 361th LeetCode Weekly Contest. Let's go. And the best time is 10 minutes. Jeez. No, I'm not going to beat that. Come on. Given how algorithm focused the site is, they should really do better with loading. This is an issue like every contest. It's slow. Okay, let's go. Divisible, non-divisible sums difference. Okay. That are not divisible by m, that are divisible by m. So the number not by the number that are. What? So the number that are is just going to be n divided by m. Come on. See, this is so slow. Oh, the sum of the integers. I totally missed that. Okay. So I'm going to do 1 to n dot map num. If it's divisible by m, then I'm going to keep it. Sorry, if it is divisible by m, then I'm going to do negative. If it's not divisible by m, then I'm going to keep it as is, and I'm just going to add them together. Right? I want to add the numbers that are not divisible by num and subtract the ones that are. So I should just be doing that. 19, 15, negative 15. Yeah, easy peasy. Did it work? I did it! Okay. 4 cores, n times 4 tasks. Interesting. So processor time. I see. Okay, so this just seems like I need to sort everything. I want to assign the tasks that take the longest to the earlier processors, and then I'm just going to find them in. Okay, so I'm going to do processor time dot sort tasks dot sort min equals 0. Okay, until task length equals 4 times n. N is processor time length. Great. So this is consistent. Minimum time. Okay, so until processor time is empty, basically what I want to do is I want to take the lowest processor. So that's going to be time equals processor time dot shift. And now I'm going to pair this with the tasks that take the longest. This should be max, not min. cur max time. I'm going to call this max time because that's the maximum time that something finishes. So cur max time is going to be time plus tasks.pop max time equals cur max time if cur max time is greater than max time, right? So what this is doing is I'm taking the earliest time and the slowest task, pairing them, see if that gets me a new max. Meanwhile, though, it's handling the next 3 most time-consuming tasks also. So 3 times, this would be tasks.pop. And then I just return max time. I'm going to walk through this one more time if it works, but I'm going to see if I have a dumb mistake first. 16, 23, great. Okay, so again I have these sorted, so this will be the lowest processor time, the one that starts earliest, and I'm comparing it with my task that takes the longest to finish, right? Because it's actually going to take the 4 tasks, but relevant to the maximum is just whichever of those 4 is actually longest. I get that from popping. I basically just add those together, and then I do this for each of the different processors. Input's valid, so it should be good to go. Okay, great. Oh boy, this seems like DP. Ooh, maybe not. Two indices and flip them both. Ooh. Oh, dang. Okay. 500 means I can't do bit masking. So there have to be an even number of indices that don't match, first of all. Second of all, if they're next to each other, I can flip them for 1. Otherwise, I can flip them for x. If they're not next to each other, I could flip them for a multiple of 1. For example, if I have 1, 0, 1, and I want to flip the 2 1s, I could flip 1, 0, and then flip what was 0 and what is 1. Like indices 0, 1, and then indices 1, 2. That's equivalent to flipping just indices 0 and 2. So I could also flip them by either the distance apart or x. Okay, so first of all, I need to figure out what ones don't match. Man, if x is 1, this is so easy. Okay, so I'm going to do 0 to s1.length dot select idx's equals I s1I not equal to s2 of I. Return -1 unless idx's dot length divided by 2 equals 0. Okay, So I handled the edge case, easy peasy. I now have all of the indices that don't match. So in this first one, okay, I just want to print this. It's going to be easier to think about. Is this going to error out? Yeah. Okay, and let's just return 7 to make sure it doesn't error out. Oh yeah, wow, 7 is wrong. Okay, so I have 0, 3, 5, 8. Exactly, good. Okay, so the 0 I could either pair with the 3, or I could pair with something else later. This feels like dynamic programming, to be honest. Min cost starting at index 0, and I'm going to say memo. Okay. So in each case, I can either get rid of something for, let's say, half of x, I'm going to say x equals x over 2.0. Okay, so when I'm looking at this, basically, for 0, I can either get rid of this for the cost of half of x, because I'm going to pair it with something else later. I just don't know what, but I know it's going to have to pair at some point. Otherwise, this wouldn't work. I already checked that it's even. So I can get rid of it for a cost of 1, or I could get rid of both this and this for the cost of the difference between them. So at each point, I either get rid of it for 1 or I get rid of it in the next thing. Perfect. That totally works. Okay, so return 0 if I equals idx's.length. This is actually going to be a really nice memo because it's only going to 500. I think I do need to memoize, but like this is O of n. It's not even like squared or anything. Return memo I if memo I. Okay. Option 1 equals x plus min cost I plus 1. Option 2 equals actually I want the last case. Return x if I equals idx's.length minus 1. Okay, I want to handle that case directly. Yeah, I could even put that in my memo if I really wanted to. No point. Okay. Yeah, that way there's no validation issues. Then I definitely have an option 2 if I made it to this step. That means there are at least 2 things left. If there's only one thing left, then I just take the one thing. Okay, so option 2 is going to be I dx is I plus 1 minus I dx is I plus min cost of I plus 2. Haha. And then memo of I is going to be whichever one's lower. Let's see if this works. Oh boy. Oh, yeah. That is not how square brackets work. I am indexing, not calling a function. What? Runtime error? Oh, yeah. Yeah. Syntax. 4, -1. Okay. I'm going to submit, but again, explaining one more time how it works. So basically, I'm finding the indices that don't match. This has to be even, otherwise I'm in trouble. So for each index, basically I have the option of either pairing that with the next thing and just going one by one and taking out that in the next, then the next and the following, etc., until I get them together. So that's just going to be 1 times the difference between them. Yeah. Or I have the option of getting rid of that and some other later index. Not sure which one yet, so I'm just going to take half the cost of x for now. I'm dividing by 2.0 in case x is odd, because it could be. And I'm just making sure there will always be a proper pair. So if I get to the end, great. If there's only one left, I want to avoid validation errors. If there's something memoized, I return that. Otherwise, my options are I take this to pair it with some hypothetical future index or a past index, doesn't matter which. Or I take the option of going one by one from this to the next one, in which case I do min cost 2. And it works. Okay, how am I doing so far? Man. There are like 5 people who have already finished. Show-offs. Okay. Oh no. Mod 10 to the 9 plus 7. This is a prime number. That's why I like it so much. Okay. 0 index, integer array nums, and positive integer k. All values nums I to... What? Okay. So num I becomes I and j, becomes them anded, nums j becomes them ORed. Oh, dang. Of course it could be 10 to the 5, so I can't even do n squared. What's my time? Are they finished? Yeah, they finished. Hey, Slava Ukraine. Okay. Let's see. Oh boy. So here I don't want to apply any operations because every pair, it wouldn't change. 4 and 4, the same or and. 4 and 5, 4 would be and, 5 would be or. 4 and 7, 4 would be and, 7 would be or. Fine. This one they do change. In general, if you can make progress with an or you want to get the biggest number possible, generally speaking. So the largest square I can get here is 15. Dang. No, that makes sense because I have 8, 6, and 5. Sure. 2, 2, 5. I can also get stuck with 6 still. Interesting. Okay. Why is that the highest? So if I do 6 and 5, that would leave me with 7 and 4, right? They both have a 4. If I do 7 and 8, oh yeah, and then I do 2 and 4. Okay, yeah, got it. Does a greedy strategy work here? I wonder. Two and 6, same. 6 and 5, 7. Okay. Sure. Okay, so first of all, I want to think if a greedy strategy works. Oh, no, I can't. That's unsquared. Shoot. Oh boy. Okay, let's ignore the time complexity for a minute. Would a greedy strategy fundamentally work? So there I'm doing okay. So I just want to see if I ever get a wrong answer here. Not a real contest, don't care about the penalty. Also, I can just do example test cases, can't I? That would be the smart way to do it. Ba-dum-bum-bum. 2, 6, 5, 8. And let's say I could take 3 of them. Does that make any difference? Oh man, that was dumb. 2, 6, 5, 8, 3. Okay. So I'm going to say while k, of course k could be up to 10 to the 5th, greater than 0, nums.sort cur equals nums.pop. Nums.each do num. I'm going to say cur num equals num and cur num or cur. And total plus equals cur squared, k minus equals 1, and then I return total. This is the greedy strategy. I take the biggest number, I and or it with everything in the array. Oof, that's not doing at all what I want it to. Oh, I have those switched. Or is the one that's bigger, not and. $74, $90, $323. That's not good. Do num I, and and here I want it to be nums I equals, there we go, 261. Okay, so this seems to work either way. And if I instead made this 1, $225. Yep, because the highest single number I can get is 15. So I think this greedy strategy works. Oh, and I need to do mod. 2, 3, 4, 5, 6, 7, 8. Okay. I think this works. I now just want to see, will this TLE? Yep. So it does work. Great. How can I make this strategy more efficient? Okay. Okay, let's think about this differently. What are my actual numbers if I do it this way? Okay. Okay, I just want to get my actual numbers. K minus equals 1. And now I'm going to say key r, and just so it still works, r dot each num total plus equals num. Okay, I just want to see the numbers I get each time. I have a theory I want to test. Okay, great. 4. So what I believe is happening here is I'm taking the bitwise representation. Here I only have one odd number. I'm going to test one more thing here. And then I'm going to explain my thinking and how I think I can make this work. So this is going to be 15, 6, 0. Well, that's funny. Okay. So basically, if I break this down into bits, I have 1 8, 2 4s, 2 2s, 1 1. So the first thing is going to take from each of those. And the next thing is going to take from each of those that are left. So 10 to the 5th. Yeah, so basically I'm just going to break each number into its bits. And I'm going to take account of the bits of each thing, deleting as appropriate. Okay, I can make this work. So count equals hash dot new 0. Nums dot each, I can type, do num while num greater than 0. Okay, I want to decompose it into bits, and I want to have my count be a tally of the bits of each number, basically. I wonder if there's a tally method for bits in Ruby. That would be fun to look up later, but I can definitely write one out myself. So I'm going to say, oh, shoot. So I'm going to say I equals 1 if num divided by 2 equals 1, then count count of 2 to the power of I plus equals 1, num divided by equals 2, and I plus equals 1. Okay. 0, so that's going to return 0. That's going to be wrong. I just want to see if my count is correct. So this should say, yes. Boom, got it. Okay. Perfect. So in this case, I do. Okay. This is amazing. So I'm just going to take 1 from each count if I can do it. Take as many k times. I'm going to take 1 from each count that still has at least 1 in it. Add those all together, square it. Worst case scenario, this is really going to be with the numbers go up to 10 to the 9th. 10 to the 3rd is approximately 2 to the 10. That's going to be 10 bits. 10 to the 9 is going to be 30 bits, so this is 30 times 10 to the 5th. That's easy. Okay. So while k greater than 0, cur_num equals 0. Pausing for a minute. Again, I decomposed it into its bits, and basically I want to take the biggest number possible. That's going with the greedy strategy. I'm going to get 1 of each bit that's remaining. So the first one I'd get 1 plus 2 plus 4 plus 8. The second one, I don't have a 1 and an 8 left, so I should get 2 plus 4. So that gets me 15, these added together. Squared, 225 plus 6 squared gets me 261. This works in general. I tested this. It seems to work. Maybe there's some edge case I'm missing, but I hit time limit exceeded first, so I don't think there is. Okay, cur number is 0. Let's say count dot each. No, let's do count dot keys dot each, because I want to modify it as I'm doing this. Do key cur_num plus equals key, count at key minus equals 1, count dot delete key if count key equals 0. And then after this, I'm going to do total plus equals cur_num squared, rather. And I'm going to decrement k. Okay. On magic. Let's go. Let me explain it one more time. I'm a teacher. I over-explain things. Feel free to skip. So basically, I found out a greedy strategy works. What I want to do is I want to, for the first number, take all possible bits that appear anywhere in the array. So here, I have a bit of 1, a bit of 2, a bit of 4, and a bit of 8. So I can use those in my first number. I get 15. Great. The problem is, each bit I can only use 1 time. So for the next number, where k equals 2, I can't use the 1. I can't use the 2 or the 4 from here, but I have a 2 here and a 4 here. That gets me to 6, and I can't use the 8. So then I have 6 squared, 15 squared, 225 plus 6 squared, 36 equals 261. That's max. Here, the highest I can get is 7. Like, these are just so redundant. Then 5, then 4. Basically, the greedy strategy works here. I get as big of a number as I can, taking all the bits, and I just do that k times, deleting the bits as I go. Okay, let's see how I did. Hey, 43rd! Amazing! Does this maybe get worse? I did get a penalty. Totally worth it, though. No. Okay, yeah. Someone could still pass me, 44. Oh, man, this would have been such a good contest. That's really disappointing. My time is 38:11. Yeah, this was Virtual Weekly Contest 366. It's really too bad this wasn't in the morning, because this would have been excellent for me. Maybe I wouldn't have taken the penalty, though, and that might have actually slowed me down. It was probably worth the 5 minutes. Anyway, this was Virtual Contest 366. Hope it was fun and helpful to watch. Now, stop recording.